So, alright, we're back in the game here. Come on, we'll take a break in a couple of minutes. So, I just got you to prove a point there. We opened up a Microsoft Word document. I got you to do a quick editing thing where we added in 10 lines of code or whatever it was. And then I got you to power off your computer. And you hadn't it saved. When you came back to it, the document was gone. It was volatile. That RAM is known as volatile memory. And you powered off, you lost your data. You had not it backed up. You hadn't got it saved thing. So, that's the thing about RAM. And RAM, when an application on the operating system is run, it is copied from the hard disk into RAM. So its instructions and all its data, it's copied from the hard disk into RAM. That's what happens. Now listen to me. The stored program concept. When you run an application, the application's program is permanently stored on your hard drive. And that is then copied into RAM. All of those instructions or data for that program is copied into RAM. So, what example? You open up Microsoft Word. All the instructions and the data required to run that application or program are taken from somewhere in the hard drive where they are permanently stored into RAM, because now you are working on that application and you want to be able to work on it a bit quicker. You don't want to be 5 minutes going to save something or 5 minutes going to do something, make it bold or that. It's now in RAM, so it's a bit quicker. So, it can be referred to RAM as main memory, primary memory, central memory or core memory. It can be read from and written to, and access to RAM is fast. So the same way that when you're doing working on your Word document, I keep using Word because it's the best example. You know, sometimes you might make a mistake, you press delete, you go back. So you're reading from your writing to you're doing it quick. Access to RAM is fast. And at any time, it will normally contain the part of the operating system currently in use, the software currently in use, and the data that the software is using. A nice little graphic there. You know, we'll see this about memory hierarchy, about speeds and that in more detail in a moment. So RAM, the last one here, computer stores running programs and data in RAM when the computer is turned on. So when you're working on a program, it goes to, when you open it up, it goes to the hard drive, finds where the data or instructions are for that stored program, and loads it into RAM, making it quicker for you to use. So when the computer is turned off, RAM becomes empty. It's volatile. When you switch on your computer, the startup instructions load the operating system from your hard disk to RAM. And in fact, we're going to have a look at this fella here now, ROM, which is read-only memory. And this is when some data needs to be permanently held in memory, even when your computer is not powered on. Now you need to distinguish here, this is still a type of main memory. It's not secondary memory like your hard drive, which is your photos and all things like that. This is ROM here now. Read-only memory is useful for storing software that is rarely changed. Like photos can be changed, Microsoft Word documents that you save and then you bring them up again and you might edit them and that. ROM is where software that is rarely changed. Can you think of an example of that? Well, an example of that, every time you turn on your computer, the boot up process that happens, that boot up process, the basic input, output, storage and all that, that is the instructions and data that is permanently stored away in ROM. And ROM stores instructions needed for boot up and what the operating system, the CPU, needs to run to start up your computer. So, here's the memory hierarchy. I'd like you just to drink that in there for a minute and we're going to chat about it in